हेलो एवरीवन, आज मैं लेके आई हूँ नई रिएक्शन जिसका नाम है बेंजिलिक एसिड रीअरेंजमेंट। ओके, सो आज हम पढ़ेंगे बेंजिलिक एसिड रीअरेंजमेंट के बारे में। फर्स्ट इज इट्स डेफिनेशन। सो डेफिनेशन ऑफ बेंजिलिक एसिड रीअरेंजमेंट इज दैट कन्वर्जन ऑफ डाइकीटोन्स। सो हियर डाइकीटोन्स conversion of diketones in the presence of base. It may be sodium hydroxide or sodium ethoxide, that is NaOET, to form alpha hydroxy carboxylic acid or alpha hydroxy esters is known as benzylic acid rearrangement. Okay, so what is benzylic acid rearrangement? It is the conversion of diketones in the presence of base, generally sodium hydroxide or sodium ethoxide, to form if we take sodium hydroxide, then the major product is alpha hydroxy carboxylic acid, and if we take sodium ethoxide, then the major product is alpha hydroxy esters. Okay, but the essential condition here is that the diketones taken essential condition is here in he- essential condition here is that the diketones taken should have no alpha hydrogen. Okay, this is the essential condition for a reaction to occur as benzylic acid rearrangement. This is the essential condition, because if the diketones taken having alpha hydrogen, for example, if I take example diketones, this is example of diketone. Okay, this is example of diketone having alpha hydrogen. As you see, this is 1,2 diketone. It may be named as, this is 1,2, so 1,2 diketone, and as you see here, alpha position is this, so alpha carbon having 3 hydrogens. Okay, so in this case, this diketone having 3 alpha hydrogens. Okay, so this diketone is not able to give benzylic acid in the presence of base, will form enolate and do not give benzylic acid rearrangement. Okay, so this is rearrangement. Okay, this is the definition of benzylic acid rearrangement, that is generally diketones having no alpha in the presence of base to form alpha hydroxy carboxylic acid or alpha hydroxy esters. But essential condition, main important condition here is that diketone taken should have no alpha hydrogen. This is very important point that must be remembered, that diketones taken should have no alpha hydrogen. Okay, for example, this is if I take here diketones having alpha hydrogen, this diketone having 6 alpha hydrogen, 3 alpha hydrogen here, 3 alpha hydrogen here. Okay, so it having alpha hydrogen, so the base, instead of acting on carbonyl carbon, will attack on this alpha hydrogen, abstract alpha hydrogen, form enolate and do not give benzylic acid rearrangement. So it is the essential condition that diketones having no alpha hydrogen give the benzylic acid rearrangement. Okay, next, moving on its reaction. So here diketone taken having no alpha hydrogen, I am taking here is symmetric diketones. Okay, symmetric diketone, this is a symmetric diketone, and the R group here is the one having no alpha hydrogen, so here R group is phenyl. Okay, so phenyl group is R group is phenyl, both R group is phenyl, and so this diketone is symmetric and having no alpha hydrogen in the presence of base OH negative, or I will take here both the bases, either sodium hydroxide or sodium ethoxide. In presence of sodium hydroxide, it will form Okay, it will form alpha hydroxy carboxylic acid, or in the presence of sodium ethoxide it will form alpha hydroxy ester. Okay, this is the reaction of this is so. Okay, I will number it as 1 and 2. This is first in the presence of sodium hydroxide, and this second in the presence of sodium ethoxide. So the name of first is this. Okay, this is alpha hydroxy carboxylic acid. Okay, the name of this compound is alpha hydroxy carboxylic acid, which is formed if sodium hydroxide is taken as base, and it is named as, the name of this compound is alpha hydroxy ester. So ester is formed when the base is taken as sodium ethoxide instead of sodium hydroxide. Okay, this is the name. Next is the mechanism of reaction. Next is the mechanism of reaction. Okay, so mechanism involves is very simple mechanism. The mechanism of benzillic acid rearrangement is very simple. Okay, so in this step, in the this is the diketone. From the mechanism you get more clear that why the reactant taken here should have no alpha hydrogen, because as you see here the reaction taking place in the presence of base. Okay, so base in case of benzoic acid rearrangement attack on, as I take here, symmetric diketone. So any of the carbonyl carbon, as both the carbonyl carbon are electrophile in nature, so base acting as nucleophile attack any of the carbonyl carbon. So this base may attack on this carbonyl carbon, or this carbonyl carbon attack on any of the carbon, as this is symmetric diketone. Okay, so it will form, first step it will form, this will form OH, O negative and R. Okay, so this migration of this bond take place here, and this is the first intermediate formed. This is first intermediate formed. Okay, in the next step, this group, this O negative migrate here, and the R group along with its electron migrate to this carbon, and the migration of O negative take place. Okay, so here important condition is that migration of carbanion. Okay, I will write here migration of carbanion migration. Okay, so in this step carbanion migration will take place. This is the essential condition. So this, as you see here, this is the carbanion, as this R group, which is generally phenyl group, along with its electron will migrate to the next carbonyl carbon and will form, as this is migrated from here, and will form O negative. In the next step, in the presence of the this product formed here, in the presence of H positive, or in presence of acid generally written as S3O positive, form the main product, which is, okay, oh sorry, I made here small mistake, that here this is double bond oxygen and OH, here is OH. Okay, here is OH. As you see from above, this only this double bond migrate here, which become double bond oxygen, and OH remain as it is. So here OH. Okay, this is the product formed here, and in the next step the main product, which is, as you see here, this is alpha carbon. Okay, carbon next to CO bond is alpha carbon. So here carbon next to acidic group, we can say acidic group or carbonyl group, is alpha carbon. So here alpha hydroxy, this is the product formed, which is alpha hydroxy carboxylic acid. Okay, this is the benzillic acid rearrangement. So this is the main product formed if diketones is treated in the presence of base, that is in the presence of base, and form alpha hydroxy carboxylic acid. And if this same diketone taken in the presence of OET negative will form alpha hydroxy ester as the main product. So depending on the basis, the two different products are formed. This is all about benzoic acid rearrangement.